Okay. Hello, everyone. Welcome back. Can you guys see me? See the screen, share the screen. Can you guys hear me?
Yes, we can.
All right, great. So welcome back to this Industrial Internet of Things workshop. This 8-week workshop is sponsored by the Yongai Metal Casting and Foundry 4.0 centers. Again, during the presentation, please mute your audio and ask questions in the chat window. You may turn on your microphone after the presentation for questions. The video will be recorded and sent to you once it is ready. Okay. So again, if you are new to this presentation, my name is Jin Zhu, and then you can find all the PowerPoint slides available at this link. Okay, so click it and then you should be in the same Google folder. Okay, we put every week's presentation on that link. Okay, so today is the 5th week of the workshop, and we will go over our first project. Okay, so let's look at the outlines. So pretty much today we're actually going to have including 2 parts. In the first part, we will set up a Flask web server to show the data obtained from a BME 280 sensor via a web page. And in the second part, then we'll create a project using the initial state. And that's a IoT platform is an example of the software as a service application, so SaaS. And we'll look at this example also today. Okay, so let's get started. This figure shows the overall system for the first part for the project. So here we are basically connect a BME 280 sensor, okay, through that I2C bus, the interface, through the I2C interface, which we discussed last week, to the Raspberry Pi. And then the data acquired from the BME 280 will be stored in the Raspberry Pi locally in some text files. And then also we will implement a Flask web server on the Raspberry Pi. And the Raspberry Pi is connected through the Wi-Fi, okay, local air wireless local air network. And then a user then connect to the same Wi-Fi can check the data via a web page easily. The most recent data will be updated on the web page also every 5 seconds automatically. I remember, I think some person asked if the web page will be updated automatically. Okay, so I indeed just add one line to the template. So now, yeah, it does be able to do that automatically. Okay, here's the summary of that components we used for this project. You're going to basically need a Raspberry Pi and a BME 280. And then also you'll need to have a computer connected to the same Wi-Fi. Okay, so the software available, it's previously, we covered, we're going to use Python. And we will also use some additional Python package for the Flask, okay? The example project, all the code and then stats list can through this link, okay? And I will just show you quickly how does it looks like in that GitHub. It's available in the GitHub. So you guys can see my screen, right? Right, so this is pretty much the GitHub. So the software and then the steps. It's just a short list of the steps that you need to go over. Okay, and then all the source code is available here. Okay, so this overview. And then let's look at the first. What is the Flask? Okay, so Flask is a lightweight web application framework in Python, and that supports the web server gateway interface or that WSGI. There are many web server software available. Some popular ones, like you probably heard, like Apache or Ninja Inks or Cloudflare. Okay. The good thing about the Flask is it is small and simple, requires a very little resource to run it. Okay, and that's why we're going to use this one on that Raspberry Pi. So we utilize it to implement a web server basically, and then provide a very basic web service. So the good thing of this is sometimes if we are just want to run a very simple applications to monitor some of the process, okay, for example, if it's just a small process, or if it is a small company, you don't want to implement really complicated things, and that's the case as Flask could be utilized. So the first thing first, you want to implement, you want to implement that, install the library for the Flask. So you probably want to check if it's already installed. If it's not, okay, it's showing over here. Then if it's not, then you will just install that Python 3 Flask, okay? Pretty straightforward. This is pretty straightforward. And then you could download. Once you're done with it, you want to download the example code to your Raspberry Pi, okay? So it's simple that you don't have to like get in the file one by one. Simply, you're going to download the whole project in my GitHub to this, using this command in your window, okay? So I'm assuming for this example is just download under your home directory. Okay, in other words, is under the dash home, your slash home slash pi. Okay, that's just your, or wherever your set up the default home directory. Okay, so if not, you may need to adjust the home path in the file, okay, which we will discuss also later on, look at the code. And since the data files are saved as the text files, okay, so let's just look at the overall the project, the file structures, because you're going to actually download a bunch of files, okay. In the file, there's two, the BM280 example and then save the data locally, PY. Those two files, just similar what you did in the last week. You're going to simply collect the data from the BM280 and then save the data to text files. Okay, that's it. Now, under these directly, we have one directly called the local site. The whole thing, all the things on the local site are for the Flask. Okay, for the Flask. So the code on this one is to create that the server, allow the user to access the data via a web page. Okay, via web page. So this one, for our demo purpose, we just put under the project, but it doesn't have to into under this one. Though you have to remember by default, the templates, this folder, okay, this directly under that, under that local sites is required. Okay, that's for that Flask. So any of that web page templates are going to be stored beneath it. Okay, beneath it. That's the O4 file structure. Okay, so O4, the implementation steps is that you collect the data. So actually you can consider two separate processes. You collect the data from the VM sensors, whatever you're doing. Another thing is created a Flex server, and which going to provide a simple web service, allow user to access those data and through a web page, right? So that's easily conveniently. And then in additionally, okay, so the last step, what we want to do is we want to schedule the programming running in the background. So like in the previously, what we run is using like Python run through that SSH command window, right? Through that command window. So we don't want that. We want this, even if I exit from that window, they're still going to running at the background. So they will keep sending data. I can, even if I log off, log out, or close my SSH window, I still can access that web service. Okay, I can still use that website to access the data, right? So that's what we try to achieve. So that's the last step. We're going to just use that clone tab to implement. Okay, that's to schedule jobs. Okay, so couple of things before we continue. I just want to mention, in order to run the code, we need to make sure you do have that right permission for these folders. After you clone it, it's supposed to be automatically fine. You know, it should has the right and privileges, permission, the right permissions. As we're showing over here, so you can see if it's just a dash, the first dash one, this means there's a file. If it's D, means what? This is a directory. Here's a directory. So followed by the three-letter R stands for the right so the right permission. Reader permission. R stands for the reader permission. W stands for write permission. X stands for the execute. Okay, the permission you can execution. Okay, could do the execute the file. Okay, so over here, which we can see, we need to make sure you do have the right operation for this temporary folder or the local sites. The reason is that you need, okay, the code itself use the template, but do not only use that HTML file under the template, but you update that file using the data. Okay, so they need to write to those template files. Okay, they may need to modify these template files based on whatever data or whatever the request from the user. Right, so you have to make sure. If not, then you're just using this command, like chmod, u plus w, write permission, and then whatever directory or the file names. Okay, so for example, if you want to add a write permission for the templates, then you're just using cmod u plus w, then followed by the templates. Okay, that's it. That's it. For the Linux system or the Raspberry Pi, all the commands are case sensitive. So this one thing you got to be careful. Okay. So let's look at the first step. First step is we're going to collect data and then save the data. That's straightforward, like what you did in the week 4. Okay. You just test the example code. Once, make sure you do need to connect the BME to 80 to your Raspberry Pi, okay, and test it if you can actually getting data. If it runs properly, okay, then you can continue to the next step, okay? Otherwise, that means some maybe I2C connection has some problems. You have to adjust so that you can go to the next step. So once you do this, you can also verify you to exit from that program, and then you check if there's any data created, okay? So you could, that log file or the data is going to create it under this name, like log, and then year, month, and then date. So you could, for example, like the today is going to be log, then 2024, 03, 05, right, .txt. If you see the file, and then shouldn't be like empty. Okay, this is the size of the file. Okay, depending how much data you generated. This is how many bytes. So this is about 643 bytes per file, right? Roughly over here in this case. So in your file, you will see that once you run, the file size should increase. So make sure it does getting the data from that sensor. That's the first step. Now let's look at the second step is you're going to build the Flask web server, okay? So one of the things is that you need getting its IP address. So for example, in this case, we're going to actually getting IP addresses like 192.168.1.212. So it depends on, you could also set up a hotspot, okay, which also works. I'm going to show the demo today using that too. Okay, so you just need to write down this IP address because we're going to use this one, right? That's the server's IP address. And then you use that address to access the web page. Okay, so what you want to do, then you're going to run the example code simply because my default, this is the code, okay, going to launch that flexible web server, okay? So once you run it, okay, it's going to server something like this, giving you the warning. Okay, that's fine. It's not for the production, but we are just using this one to test it out, see if it works. Do you want to do that first before you schedule jobs using the clone tab? Okay, so you just test it out, and running on this one is in the local host. However, we connected to the Raspberry Pi through SSH, right? So if you do actually run the Raspberry Pi and connect it to a monitor and mouse and keyboard like a single board computer, you could use this to access it. But if you are running like me, that connected through that SSH, okay, in that cases, then I'm going to use this one on my computer to access that web page. Okay, so over here is that you first run this one first, and they're going to display something that means what it is ready. Okay, that Flask app or the server is ready, so I can actually to access the data through the web page. Okay, so the IP address over here need to be adjusted. Whatever IP address of your Raspberry Pi will be here. And by default, the Flask web service use the port number 5000. So we're going to just have a colon, okay, colon followed by the 5000. The default HTTP is actually, the port number is 80. Okay, for the Flask, they use the default port, different one, use the 5000. Okay, so, and for the templates file, we have a different templates file for the different purpose. And the two are mainly we use the 1 is update, which is going to be getting the most recent data, update every 5 seconds. And for the index HTML, probably not the best name, but it's just a web page template display the result for a specific date and with the download available. Okay, so you can click it and download the data in the as a .csv file. Okay, and so that you can process the whatever you want. Okay, so let's look at this is an example just showing you're going to have the address bar, then the data will be updated over here. And for this one, only the most recent result up to the 100 entrants are displayed. And it is in the reverse chronological order. So that the newer ones are on the top, okay, on top. So this is one example shown there. If I want to, okay, the project, what I example code implemented is that if we want to obtain the sensor data for a specific date, then you will add the data with this format. Okay. After the host name. So just like over here in this case, if I want to get in the data for May 23rd, then you're going to get this. If that data, the data for that data is not available, the system will just giving you an arrow. Okay, we'll just choose your arrow, indicate it's not available. If it's available, then it will just display the data. That's it. On the other side of the page, so when you launch over here, right? They will, whenever you're trying to load a page, they will automatically display, update the status. Okay, here's just showing some of the status. So if I getting successful, also the typically will be like 200. You're going to be see the 200 as successful getting the data. Okay, so once you finish this one, meaning what? It's okay. The flexible web server is running okay. Okay, and then you can just use the Control-C, exit the program. And now we are ready to schedule a job. Okay, schedule a job. Okay, so how we're going to do this is we're going to use the Chrome tab to schedule some programs or jobs running in the background periodically. Okay, so for example, if I want to clean up the older data, if I want to the sensor to want this obtain the sensor data, right? And then running the service, running that Flask web server, right? So you want to run in the background. So we'll use the Chrome tab over here. So how to do this is just use the Chrome tab -E. Okay, the first time when you run it will asking you to choose which edit to use. I would just recommend it just using the Nano. It's pretty easy and straightforward to use. And then you choose that, you're going to see a file like this one, and you just add some of the lines. So let's look at what does that mean. This one is meaning if I'm going to reboot, whenever reboot it, I'm going to run this Python code after the 20 seconds delay, okay, sleep 20 seconds, and then you do this. The reason we want to wait for the 20 seconds is to make sure the network and I2C are ready. Because if the just getting started, all the resources like, for example, that I2C bus may not be ready yet and may could potentially cause some problem. But again, you could adjust this delay, okay, like 5 seconds, 10 seconds. If you have Raspberry Pi 4B, probably needs less time to boot up every resources. Okay. So this tool is just one run the command on the back. And then this line, okay, over here is just meaning we want to reboot midnight every Sunday. So over here you see this is the month, the minute, hour, 00. So at the 0 minute, 0 hour, and then over here is any the day of the week and months, and then day of the week. So the 0, you're going to just day of the week 0 is referring to Sunday. Okay, so each week starts with Sunday, meaning I will just reboot midnight every Sunday. The reason you may want to do this is sometimes when your system running over a long time, okay, it could affect some performance and some issues. So you could do that, let the system just reboot once every week. Okay, also that be one of that example jobs that you can schedule. You could also add more on this over here, depending on what you want. So once you finish, then again, just like the typical use for the nano, okay, you just use Control X and then yes, and then exit, okay, exit. So then they will just say, okay, we'll update or initiated the clone tab job. After that, then you have to reboot the Raspberry Pi. Okay, you're going to reboot it, so the system going to actually run that, and then you can reconnect to the Raspberry Pi. Once you do this, now even if I do not run the Python command, and you can check if the process already there. Okay, it should be already there, and then the system should work. Okay. Then you can just using this one, even if you exit from that the window, you don't run that program in the command line, is still going to be able to allow you to access the web page. Okay, so we'll just show you quickly a demo. Okay, so I already set up in my sensor through a hotspot. So you can see, you could check, this is my IP address, okay? And I also could just check if there's any Python processes. Oh, sorry, it's wrong. Big fat finger. Okay, so you see over here is IoT. This one is running periodically. It's on the sleep. Okay, so it's running fine, and then I could just well, I launch a web page. Okay, and then you guys can see it over here. Okay, so that's the web page, which you can see they updated. Currently, I just getting data pretty much every the sensor data every 5 seconds. Okay, getting the BME data every 5 seconds. So that's the temperature, pressure, and then relative humidity. Okay, so they will just update this. And if I want getting the data, for example, okay, for example, I would like getting the data for a specific date. Okay, so for example, let's see, yeah, How about the state? Okay, so that's the data for the February 28th. And this one, we including another BME center sensor, but also at that date, I have a small couple connected. So over here, the 3 data: temperature, pressure, and humidity, and then small couple connected. And I can just I can download the data. And then they will just allow you to, whatever data you want to download it. You can save it, which is a CSV file. And if you're getting another date, then they will just change automatically. Let's see, how about 3? I believe I also have the data, that one. And if there's some date, okay, for example, I don't think I have this data, then the system will just tell you the data is not available. Okay, so these are showing an example. The good thing about this one is it doesn't really need to have this one open. Okay, you don't need to run in the front. It's always run in the background. So even if I exit it, it's not going to affect it at all. The data will still be updated every 5 seconds. Okay, so this is that example showing over here. Any questions so far? So pretty straightforward. You just run that example code straightforward. Okay, so a few notes about this. Okay, the code, which is the fully common. So if you see over here, if I want to know, okay, what is that looks like, I can go over here and then just see, okay, local site, which you could see over here. That's the code. If you would like to read it, and try to understand and modify it, that's there. And then you could also, for example, like over here, the BME 280 example, that's the code. Okay, that's the code. Pretty straightforward and easy to use. Okay, so if you want to have multiple nodes uploaded to a central computer or a dedicated Raspberry Pi, you can also do this. Okay, so in the cases, you could just implement one of them. You could connect it through, like, for example, a secure file transfer protocol, use the SFTP. That's also possible. That way, you could also put all the data into one single computer. Okay, so here has some limitations of this one is that we noticed that creating a website runs over the HTTP, so it is only recommended to use within a trusted local area network. Okay, if you want to open the website to public, I would not using this method. Okay, but in many cases, the Flask is just simple and easy to implement. If I just want to do it, okay, locally in my office or in my shop, then you could use it. Okay, you could use it. If you want to implement the encryption and verification through the TLS and apply for the SSL certificates, that will be more complicated. Okay, so that's some of the things I would like to mention. But I think this is just a useful application example. For sometimes you only, I just need a little bit of things, not requires a very complicated task. And that is what this example could do. Okay, any questions? If not, okay, we will look at the second part. We'll look at the second part. So the cloud-based application, now we see this example obviously has a limitation because we only store the data locally on that Raspberry Pi, right? So, but most of the time we want to store the data in the cloud, some way in the cloud, right? It's easier to store and back up the data. So we see also they have great predicted have 20% or more growth each year, that from now. The typical service for those cloud-based applications, then including infrastructure as a service, or called IaaS, platform as a service, back-end and service, and software as a service. So from this one, I showing over here that development flexibility is going to decrease, okay, from the top to the bottom. So software as a service has a less flexibility in the development. However, the development workload is also the least one, okay? So from the maximal to the minimal, which is understandable. It was very flexible, meaning what? You need to develop a lot of stuff by yourself, okay? Quickly go over some of these examples. So for example, many companies provided this kind of structure. So the infrastructure of the servers, network, and storage as service to the user, you could just, purchase those services directly, but it does not including any of the middleware or runtime service user can develop the building on this system, but it does requires a lot of work. So very popular one is a platform, although it does not including everything, but it does including the operating system, middleware, and runtime and development tools. So it can speed up the development process significantly, right? Significant. This is a platform as a service. For the back end as a service, will provide further features on top of the PaaS, so such as the user management and authentications. Right, there's many users. How you're going to do the authorization and the authentication? That's really challenging. Application check, hosting, like we did for the Flask, right? The hosting, but it's a local. However, you may want to do some hosting in the cloud. What you do, and also the payments. So there's many platforms also provide this service. They could focus only on your front end development. Okay, most of that back end has been taken care of by the service provider. The last one is software as a service. So they provide the application service directly to the users, such as your Salesforces and Zooms. Okay, is understandable. And many of these kind of SaaS are available. It's ready to use, very small. So we're going to need minimal coding for the configurations. And what we will look at, one of them is the initial state. Okay, today we'll just look at the initial state. So what's the initial state? It is just the IoT platform for the web applications of the data visualizations. So you don't really need to care about how to create the front end web application. The provider already provided that, included that. So well, very easy to use. One of the things is that though you have to pay for its service, if you're a student, it does including like free, I think free service, have some limitations, but it's not really expensive. For example, for the individual plan is like $10 per month. And then 1 year data retention, meaning your data, they are going to hold the data for 1 year. okay, for 1 year, and that's some limitations, and then allows those 3 million incoming data points per month. Okay, so depends on your needs. It might be enough. Okay, could be not enough, then you can go further to the enterprise plan, which will be more expensive. So how to do this? Let's look at, okay. Simply you will need first create an account. Obviously, use their service, create an account. After you log in, then you're going to see an interface. Click on the app launch. Once you do the app launch, you can add whatever names and click what create a string bucket. Okay, so you will just click on this one, create a string bucket, and then give it a nice name, which you can remember. And then you need to remember what there's bucket key and access key. Those are the keys that used for your Python code. And then they use this bucket key and access key allow your program code to update to their string bucket. Okay, so they're going to be able to update the data to that initial state. So the example code is already including in that file. So one of the thing, if you look at over here, most of files for that the first part, but theirs do have one code, initial state BME 280. Okay, so this one is already being available under that clone. So if you did the clone, the file should already be available. Okay, under the folder. So what you want to do is I need to modify the file. Okay, before that, what you could do is over here, I could need to again install that initial status string, that package or the library provided. So you just install it, pip install ISS string, okay? IS string, which is initial state streamer, okay? So once you include it, and you could run the code, use this one, okay? Run the command, nano, just to modify this file. At the top of the file, okay? At the top of the file, you're going to see some of the lines. So for example, over here, to go back over here, this the code, and then run, fine, okay. So you see over here, this is the portion that you may change depending on what's your bucket name, what name you want to name it, the sensor, and then what is the keys. Those are all need to be adjusted based on your own project, okay? Based on your own project. Once you finish that, you can run it. So what we see over here, this the initial, we could look at the next slide, is the initial state examples. And then the layout is not very flexible, but pretty much serves the purpose. You could see it easily, okay? They could change the layout by click on the edit tiles, or you could view the waveforms over the different data, and then you can also observe the file sources by click on this button, okay, on this button. So the last thing we will is going to look at this example, okay? Going to look at this example. So we see over here, this is, hold on, okay, so this is an example. So we can see over here, that's the some of the data. This one, I was not connected over there, but this is the data we're showing. Now I believe currently I stopped. Let me check. We're just trying to. Okay, so we're going to just load this one as. Okay, so we'll just run the code, and then you should be able to see the data automatically updated. Okay, so you should be able to see the data updated over here, which is, see that this one is moving. Where's my data? Okay, so this is the time which I can just. Looks like those are what time? 12? Is it 12:47 now? Yeah. So those are the data. Some of the thing a little bit confusing is that those are, see, this is the point at which they have the data. Obviously, you can see over here, I actually stopped sending the data for some time, right? And then this one is actually starting to send the data again, which if I enlarge this portion, okay, you can see over here, that's the point at which we started running the data. So a little bit confusing is those portion, see over here, they still have a line, but that line is actually doesn't have the data yet. You can see it's a different, you see the pointer, right? It's moving if it does have the data. Well, over here, there's no data. Simply it's just the way they designed, and then you cannot change it really. So over here, it's the same thing. You can see the temperature changes only a little bit, and then that's a humidity. I don't know if I may change. If I touch the sensor, it may change it a little more, but it's a room temperature. So anyway. Okay, so this is a demo. Any questions? Any questions? Here's some of the reference documents that you can use. And then again, if you want to try it out, the GitHub process, you can follow that one, which is pretty straightforward for you to use. Somehow I cannot see my camera today. I'm not sure if you guys can see me. But that's pretty much for today's. Any questions? You guys have any questions? We have a couple minutes left. Anybody tried? Like, I think today's project question. Yeah, Ben?
Yes, I was curious
Uh-huh.
that the data is being streamed to the cloud, and it's also being saved on the device locally, correct?
Correct.
Is there any, I would say, a handshake between the cloud and the device? If you have internet cut off, will it backfeed or update the cloud with the information that the cloud didn't get if the internet connection is lost?
That's a good question. You mean that, I mean, for the current implementation for the initial string, this example, it does not.
Okay,
Yeah, there's a way you could implement, but will be more complicated. Yes.
okay, because
So,
I work with a system that it doesn't do that,
mhm.
and that's one of the shortcomings of the system I've had in the past, and that's one of the things I need to overcome.
Yeah. So if you use a mosquito, I believe they have a way you can control if the data does not go through, they will catch it and then publish it whenever it's available. So I believe there's way, but with this initial state implementation, I don't think so. The good thing about this one is very straightforward, very easy, just one line of the code, and then you can upload the data to the initial state. Okay, any other questions? Okay, so I think then that's it for today. And then if you can, fill out the short survey. See you guys next week.